Let's look at OpenStax College Physics, Chapter 11, Problem 46. A. What is the density of a woman who floats in fresh water with 4% of her volume above the surface? This could be measured by placing her in a tank with marks on the side to measure how much water she displaces when floating and when held underwater briefly. B. What percent of her volume is above the surface when she floats in seawater? So let's write down the things that we know. We basically just know that her volume above water divided by her total volume is 4%. All right, and what we're looking for in part A is the density of the woman, and in part B we're looking for V above divided by V total in seawater. All right, so here I have a drawing of the woman floating in with 4% of her body weight outside of the water. And the reason she's floating is because the sum of the forces that act on her is 0. So if I drew her weight, I know that her weight is balanced by the buoyant force. So I'm going to say that in part A, I have, by Newton's second law, sum of the forces acting on her is mass times acceleration, but acceleration is 0 because she's floating in equilibrium. So then I have the buoyant force is equal to her weight. All right, but I know that by Archimedes' principle, the buoyant force is the weight of the fluid displaced. So I can set these two equations equal to one another. So I have the buoyant force here is equal to the weight of the woman, and I have the buoyant force here equal to the weight of the fluid displaced. So that means that the weight of the woman is equal to the weight of the fluid displaced. So weight of the woman is going to be mass of the woman times g, and that's equal to the mass of the fluid displaced times g. So I'm going to cancel out a g. Then I can write mass as density times volume. So I have the density of the woman times her total volume is equal to the density of the water times the volume displaced. So what does that mean? The volume displaced is all of this part of the woman that now takes up the water that used to be here. So the volume displaced is actually her entire volume minus the volume that she's sticking out above the water. So then I have density of the woman times her total volume is density of water times her total volume minus the volume above. So I just want to know how much of the woman is underwater. Then I solve for the density of the woman, and that will be density of water times V total minus V above divided by V total. So that's density of water times 1 minus the 4% that I was given before. So that's 0.0400. And it turns out that then that the density of the woman, if I plug in density of water as 1,000 kilograms per cubic meters, I end up with 960 kilograms per cubic meter. So that would be the density of the woman. Now in part B, I want to know how much she is above water in seawater. So I'll basically start with the same thing. So I'm going to use this equation where I have the weight of the woman equal to the weight of the fluid displaced via Newton's second law and Archimedes' principle. So I have weight woman is equal to the weight of the fluid displaced, and that is mass of the woman times g, which is mass of the fluid displaced times g. So that is mass of the woman, density of the woman, volume total equals density of the fluid times volume displaced. So that means that density of the woman, volume total, will be equal to the density of the fluid, and the volume displaced is her total volume, the woman's total volume, minus what is above the water. So volume displaced is this much. Volume above is that much. So the sum of this volume and that volume is the entire volume of the woman. So then we're looking for, so let's say that the density of the woman divided by the density of the fluid, which now is seawater, is V total minus V above divided by V total. So that is 1 minus V above over V total, and that's what we're looking for. So V above over V total will be 1 minus density water divided by density seawater, and that is 1 minus density of the woman is 960 kilograms per cubic meter. Density of seawater is 1025 kilograms per cubic meter, and that turns out to be 6.34%. So she will float with more of her body above water in seawater than she did in fresh water.